According to a survey, 10% of Americans are afraid to fly. Suppose 1,100 Americans are sampled. What is the probability that 121 or more Americans in the flight are afraid to fly? Write your answer as a percentage, round to 2 decimal places, and do not truncate the standard deviation. Use all the decimals when calculating this. Okay. So record, okay, so it says, according to a survey, 10% of Americans are afraid to fly. So they're definitely giving us a percentage here, or a proportion, of Americans who are afraid to fly. And they're also giving you an N. So and they're asking, what is the probability that, 21% or more, and what they really mean is 121 or more of the 1,100 are afraid to fly. So really they're giving you a proportion, and they're asking, what is the probability that your sample is going to have that proportion or higher or more, right? So this is definitely a proportion problem. Proportion, I always kind of am suspicious that it might be a proportion problem whenever they give me a percentage right away, because that's not usually something they do with mean problems. However, they could give you a percentage in a mean problem, usually not. And they usually always have to give you the mean. And when they ask the probability, it's always what is the probability that, a mean or average will be greater than something or less than something. So this one is definitely a proportion problem. So since it's a proportion problem, we are going to want to use the sampling distribution of the sample proportions, and the formulas that go with that are the mean of the population sample distribution of the sample proportions is equal to the population proportion, and the standard deviation of the sampling distribution of the sample proportion is equal to the square root of P1 minus P all over N. And take the square root of that, of everything, all of everything there. My square root symbol is a little small. So let's work on this first part. Or actually, just from the information given originally, we can figure out what the mean and standard deviation of this distribution is. We're going to be calculating probabilities, or at least the probability of a sample having a certain characteristic. Well, I guess it would be important to make sure that this is normally distributed. So I can draw it with this bell-shaped, right? So we have to make sure that N times P times 1 minus P is greater than or equal to 10. They don't really talk about that in this part, and this kind of has to be true for us doing this work. So usually, sometimes I accidentally skip over that part, but we technically in real life, we should make sure to do that. So N is the number sampled, so 1,100. And then the P, population proportion, this is the one that they state as a fact in the beginning of the problem. 10% of Americans are afraid to fly, so we'll put 0.01. Or I'm just going to put 0.010. The last zero is not important, but just so that you kind of can see that I turned the 10% here into decimal, and that's where that P is coming from. Okay, so I'm going to plug in 1,100 and then plug in 0.10, and then 1 minus 0.10, and see, I'm checking, is that greater than 10? Hopefully it is. So 1100 times by 0.1, enter, times by 1 minus 0.1, enter, is 99. So that definitely is bigger than 10. So we are good. This is normally distributed. So I can draw the sampling distribution of the sample proportions as normally distributed like this. I can say the mean, the peak of that is going to be the 0.1. Since that's what the population proportion is. Now we can calculate the standard deviation of that distribution. So that's going to be the 0.1 times 1 minus 0.1 all over 1,100. And so we can do that calculation. Sometimes I do this in pieces. I do just the numerator here, find a number, the denominator, and then divide by that denominator, and then take the square root of everything. But sometimes I forget to do square root, so I kind of like to do that first. So second x squared gives me the square root symbol. Then I'm just going to put in parentheses so I know they know it is the numerator of everything. I'll put in a second parentheses so that everything is behind this square root symbol. 0.1 times 1 minus 0.1, which is 0.9, but okay, all in parentheses, that's the numerator. Then divided by 1,100 and 1,100. And we get this 0.009045. I'm going to keep all decimal places there. These problems have been very picky, and a lot of them say write your answer to 4 decimal places. If they want 4 decimal places, you need to keep everything out to at least 8 decimal places in. If not, try to keep every single decimal place when they ask you for that many decimal places of accuracy. So let me try to write down what this was. And that's what was throwing off. If you truncate this number in any way, most likely you're going to get this answer wrong. So it's 0.009. That's going to take me a while. 0.009, 0453, 0453. 4034. Ideally, when you're doing calculations, you should never, truncate and just use 0.009 as your standard deviation. I mean, I might do that when I'm showing you guys just so that I don't have to write out all the decimals over and over again. But when you're actually doing the calculation, you should try to be as accurate as possible and never truncate or round in numbers before the final answer. All right, so to go back to the part, so now we found the mean and standard deviation, and we knew it's normally distributed of the sample distribution of the sample proportion. Next, what is the probability that 121 or more Americans are afraid to fly in the survey? So 121 of the 1,100 are afraid to fly. So this sampling distribution only finds the probability of having a certain sample proportion. 121 is not a proportion. A proportion is like is always a decimal. Or you can write it as a percent, as like 60% or 70%, but it's never going to be bigger than 100%. It doesn't make sense to have 110% of the population or something like that. So it's always going to be a decimal. And this is not a decimal because this is not the proportion, and we can't use this number. That what we have to do first here in part A is we have to find the sample proportion coming from if 121 were afraid to fly. So the sample proportion is X over N. So X here is the number of people with our characteristic. So that's 121 over the 1,100. that is how we're going to get the sample proportion. And that's what we need to find this probability. So 121 divided by the 1,100. Oops. 121 divided by 1,100 is 0.11. So what we're gonna do is, I'm not exactly sure where 0.11 is. I'm just gonna guess. I know it's to the right here of 0.10, right? So I'll just write it here, but it may be way over here. I didn't like put all. I didn't put the standard deviation and write everything out. But I'm just gonna assume it's somewhere to the right. It might be a lot further to the right. I'm not sure. But the picture looks something like this. And because it said or more, that's why I'm shading to the right here. Now to find that answer, you have to do normal CDF because it is normally distributed. I put the lower bound in this picture is 0.11. The upper bound it's shading until infinity. So that is, our calculator can't really understand that. So it's positive 1 e 99, and you have to put positive 1, but 1 e to 99, and then or you could put 100,000, just positive 100,000. You know, just a really large number will give us the accuracy, enough accuracy. Which 199 is a really large number, but okay. Then the next step is to put the mean, which is then the mean here is 0.1. We need the 0 there, but okay. And then the standard deviation is the standard deviation from down here that we got earlier. So it's 0.009045. And like I said, I'm warning you here, do not truncate the standard deviation. Use all the decimals. That's what I meant when I said that. Use all of these decimals. Or you might be able to put the whole formula into that as well. Sometimes it'll allow you to do that. I'm not so sure it will allow us to do that in this situation, so I'm just going to put all of them. And that's what I put into my calculator here. Second, just bars, and then normal CTF. My lower bound, the 0.11, comma, 1 EE 99, comma, 0.10, but I'll just put 0.1, and then 0.009045 34034, I believe. And now I can end the parentheses. I get an answer of 0.13456. 0.14. So it would to 4 decimal places. I think they want 4 decimal places. Oh no, right? Your answer actually two decimal places, I guess. Okay, so but turn it to percent first. So you would do 2 to the right. So that'd be 13. And then 2 decimal places would be 13.45. So that's what ends up being our answer. Make sure to turn it to a percent first and then round to 2 decimal places, so 13.5. Not sure if you have to put probably not going to have to put the percentage in there, but you might just want to include that. All right, so part 2 is very similar. We already did all the hard work of finding the mean and standard deviation. It just says, what is the probability that 165 or more Americans are afraid to fly? And write your answer, percentage around 2 decimal places. So we're going to do the same exact thing. The only thing, it's going to be normal CDF. All that's going to be the same. The mean and standard deviation are going to be the same. It is 165 or more. So the upper bound is still going to be 1E99. The only thing that's going to be different is this starting proportion. So we always have to put, when we're doing these, a p hat needs to be one of the either upper bound or lower bound. And to find the p-hat, sometimes they give you the p-hat right away, but sometimes they give you the x, that is this a particular number of people with your desired characteristics. That's what they gave us here. So 165 over 1100. And let me get what and you might even be able to like just input that and not have to calculate it really here, because that's important. That's accurate to a lot of decimal places as well. So one thing I can do, everything's so much the same, I can do second enter, and that gives me the entry that I just entered again. And now I can go back in and just change the 0.11 to, and I'm going to put the 165 over 1. Let's see if it takes that. $165 divided by 1100. And it does take that. Just press enter, and then that's my, wow, my answer is basically 0. So let's just double check that answer. Yes, so if I first, I would turn this to a percent. So I move it twice to the left, which as you can see, it's when I then round it to 2 decimal places, I go to the 3rd decimal place after turning it to a percent, that would still be round down, so it'd still be 0. So this rounds to just 0. So our answer for the second part is just 0. Okay. Now, the next part is that they say, what is the probability that 8% or less of the Americans answered were afraid to fly? So this one, the first two looked a lot like this picture over here. The second one, but this last one, it says 8% or less. So that picture is going to look different, right? So, and notice they do give us a proportion right away. So instead of giving us the number of people with our characteristic of just the X, they give us the proportion. This is the p-hat. So we don't have to do this step. We just put this, our 0.10, 0.1 was in the middle, 0.10 or 0.1 that was in the middle, and then this is 0.8 over here. So 0.8 or less is over this direction. So our lower bound is going to be negative infinity or negative 1e99. Because when we go far to the left here, you're going out to negative infinity. And we're going to have the same mean and standard deviation that we did a minute ago. So I'm just going to go to my calculator. I'm going to do a second entry again. And now I'm going to go back and I'll leave the mean and standard deviation the same. And the only thing that's different change are my upper bounds and lower bounds. My new lower bound is negative e99, negative 1, second comma, which gives me the e to the 99. And then the second value here is point. I had to turn the 8%. Ooh, it's not 0.8, that's 80%. My mistake. Let me just draw your attention. I made a mistake right here. 8% as a decimal. I always have to write this out because I'll make a mistake. 8% as a decimal, I move it twice to the 8%. Converted to a decimal, you have to move it twice to the left, which would be 0.08, not 0.8. Good thing I caught that, right? Okay. So I want 0.08 to be my upper bound here. And there's my answer. It's I'm going to move the decimal twice to the right to make it into a percent. So it's 1.35%. And I don't think they want you to put the percentage sign on there. But let's just double check that answer. 1.35. Yep, that's exactly what they wanted. All right. Well, I hope you found this very valuable. I would just be very careful when you're doing these proportion problems. As listen and be attentive to whether they're giving you actually the X number, that is the number of people with your certain characteristic in the sample. If they are giving you an X number, then you have to divide it by the total number sampled to get your p hat, your sample proportion, or if they give you a percentage right away, then you don't need to do that extra step. So you just have to be really careful about what they're giving you. Are they giving you the X value, or are they giving you the sample proportion? All right. Have a good day. Bye.